Okay, so we are going to talk about exponential growth and decay. Exponential growth occurs when a quantity increases by the same rate over time exponentially. And so we're going to learn two new formulas, okay? Both are going to be pretty similar, just one minor difference. So this formula, broken down, A is referring to the first term, which means the original amount in the word problem. Then rate is given as a percentage that we're going to need to change to a decimal, so I'll go over how to do that. And then T stands for time in years. Okay, so if I look at number 1, the original value of an investment is $1,400, and the value increases by 9% each year. Write an exponential growth function to model this equation, then find the value of the investment after 25 years. So let's first break down what my terms are. And I'm just going to jump into the formula. So y equals, my original value is 1,400, parentheses 1 plus, my rate is this 9%, okay? But we don't want to leave it as 9%. So I'm going to show you how to do it by hand and then how to do it quickly in the calculator. So 9% changed to a decimal means I move the decimal twice to the left. So the decimal here is after the 9. And so if I move it twice to the left, it's 1, 2. So it's 0.09 as a decimal. Now, to do this quickly in the calculator, all you have to do is do 9 divided by 100. And it does it for me because the percentage is out of 100, so 0.09. So whichever method you want to choose, I'm going to do both. Then raise to the power of t, which is 25 years. And there's my equation. But then all they want you to do is type this in to see what I get after 25 years of 9% growth. So 1,400, parentheses 1 plus 0.09. And then to do the exponent, I'm going to do this raise to the power of button, which is underneath clear, and then 25. Okay, now, since we are talking about money, I need to round to the hundreds place. So my answer is $12,072.31. So there's my answer. Okay, so it's going to be the same for the next 4 problems, so I'm just going to jump in. The cost of tuition at a college is $12,000 and is increasing at a rate of 6% each year. Write an exponential growth function to model this equation, then find the tuition cost after 4 years. So my original cost was $12,000, and it's 1 plus, my percentage is 6%. So 6%, move the decimal twice to the left, is 0.06. Or I can do 6 divided by 100, which is 0.06 as well. Then raise to the power of 4 years, since that's how much time went by. And then I just trust my handy dandy calculator. And after 4 years at a 6% increase, my amount is $15,149, and rounding to the hundreds place is 72 cents. Number 3, the number of student athletes at a local high school is 300 and is increasing at a rate of 8% each year. Write an exponential growth function to model this situation, then find the number of student athletes after 5 years. So my original amount was 300 people. 1 plus my rate is 8%, which when you move the decimal twice to the left is 0.08, or in the calculator 8 divided by 100, raised to the power of 5. Now, since this one's a different situation, the last 2 problems we were talking about money, so we had to round to the hundreds place. But since we are talking about people, we cannot have a decimal answer in this problem. So we're going to round to the ones place. So this isn't 440, this is 441 students. Okay? Annual sales for a company are $149,999 and are increasing at a rate of 6% per year. Write an exponential growth function to model this situation, then find the annual sales after 7 years. Okay, so my original amount was this big amount, $149,999, parentheses 1 plus my 6%, 2 decimal places to the left, or 6 divided by 100 is 0.06, and then raised to the power of 7 years. So 14999, parentheses 1 plus 0.06 raised to the power of 7. Since we are talking about money, I can have a decimal, so I'm going to round to the hundreds place. So this is $225,543.04. Make sure you round correctly. Last one on increase. The population of a small town is 1,600 and is increasing at a rate of 3% per year. Write an exponential function to model this situation, then find the population of the town after 10 years. So my original amount was 1,600. 1 plus, my percentage is 3%, moved 2 times to the left is 0.03, raised to the power of 10 years. So 1,600, 1 plus 0.03. raised to the power of 10. Now again, since we are talking about population, I cannot leave my answer as a decimal. So we're going to round to the ones place. So it's going to be 2,150 people. Okay, so what's nice about growth and decay is there's really not much of a difference besides the formula. And the only difference in the formula is whenever I have growth, we're going to add 1 plus the ratio, or the rate, I apologize. And when it's decay, I'm going to subtract 1 minus the ratio, okay? So let's just dive right in. The population of a town is decreasing at a rate of 1% per year. In 2000, there were 1,300 people. Write an exponential decay model to function this situation, then find the population in 2008. Okay, so my original amount was 1,300 people. 1 minus this time, since it's decay, because it says decreasing, 1% written as a decimal is 0.01. And this one, they want me to figure out how many years actually went by. So from 2000 to 2008, that's 8 years. So then I'm going to type this in my calculator, no different except the minus. So my answer, since we're talking about population again, we don't want to leave it as a decimal. So when I round to the ones place, it actually ends up being 1,200 people. And the reason for this is the 5 changes the 9 to a 10, which piggybacks and changes that 9 to a 10, which changes the one before that to a 2, so 1,200. The value of a car is $18,000 and is depreciating at a rate of 12% per year. Write an exponential decay function to model the situation, then find the value of the car after 10 years. So my original amount was $18,000. 1 minus my percentage is 12%, but when moved twice is 0.12. And then my time in years is 10 years raised to the power of. So I'm just going to type this in. Again, it's minus and not addition. And so my answer is, since we are talking about money, we are going to leave it as a decimal. So it's going to be $501.30. A farmer buys a tractor for $50,000. If the tractor depreciates 10% per year, write an exponential decay function to find the value of the tractor in 7 years. So y equals my original amount, which is $50,000. 1 minus, because it depreciates, 10% written as a decimal is 0.10. and raised to the power of 7 years. So you kind of get the hang of it. It gets pretty repetitive. It's just different values being used. Since we are talking about money, my answer can be a decimal, so it's $23,914.85. An investment of $8,200 loses value at a rate of 2% per year. Write an exponential decay function to find the value of the investment after 9 years. So y equals my original investment, which is $8,200, parentheses 1 minus my 2%, move the decimal twice, is 0.02, and then raised to the power of 9 years. So 8,200, 1 minus 0.02, raised to the power of 9. Since it is money, we can have a decimal. So my answer is $6,836.73.